Okay, I think I finally am ready to start. I hope you hear my voice, because I found only my old headsets and I'm not sure if these work. Okay, it's been a while we have had last lessons. I was in holiday. I was traveling in Rhodes Island for a week, and it was a very nice holiday. Here in Finland it is quite cold already. Many days it has been below 0 centigrades, at least at my hometown, which is about 70 kilometers from Seinäjoki. In Rhodes Island it was about 25 degrees, and that is a temperature which we all usually have in Finland only maybe some weeks during summer. We are used to much colder temperatures. Okay, I will start a new section in this course, and it is also good to see you all after this long period here. I will start a new section which is analytic geometry. I will use this paper because I need to draw some pictures here, and it is easier to draw those, for example, lines when I have these lines in my paper. So this is analytic. I don't know how I should pronounce that in English. Analytic geometry. In Finnish, it is almost the same. It is analyyttinen geometria. And I will start with some simple cases there. First thing I will take here is the distance between 2 points. Distance between 2 points. In Finnish it would be kahden pisteen etäisyys. Kahden pisteen välinen etäisyys. In Finnish we say it almost in opposite order, because kahden it's 2, pisteen is points, 2 points, and välinen means something like between, and etäisyys is distance. So if you translate this in English, 2 points between distance, the distance between 2 points. And let's take example first. Calculate the distance between points. For -1 and 7, 3. Well, actually this is quite simple problem, because when we draw a picture of a case where there are 2 points in plane coordinate system, I will draw here this coordinate axis. This is a universal drawing. It is not the same as in this example. For example, we have this kind of situation that there are axes here, and then this is this horizontal axis. X is called X, and this vertical axis is called Y. In Finnish, we call those. It is almost the same name as in English, or it comes from English, I think, or some other language which use almost the same word. We call this akseli. This is in Finnish x-akseli. Oh, sorry, you can't see that raw. X-akseli, we say X, this letter, and this is Y-akseli, the same situation, Y-akseli. And then there are some points, let's say here we have 1 point, let's call that with the letter B, and here we have another point which is, for example, Q. And then we have coordinates with those points. Let's say this B has a coordinates x1, y1, and this Q has coordinates x2, y2. In Finnish we would say x1, y1, or actually x1, y1, but simple. We use the shortened version of that word x. And here x2, y2. By the way, point in Finnish, it is, oh, actually I said that piste is point. One point is yksi piste. And then we have this distance here. I will draw it with the line or line segment, and mostly the letter we use, I think in many formula books we use the letter D. It comes from the word distance. Well, there is somewhere in this this formula book, but I didn't find it yet. Let's try to find it later. So let's call it with the lowercase letter D. And in this case, even though you don't remember the formula, well, I will try to find it from my formula book, because it's I think I should find that, but here it is actually the same words here. Kahden pisteen välinen etäisyys. So here you see the formula. You may remember this, of course, if you have used this formula, you quite easily can start remembering what is the formula, or at least how to use that formula, even though you don't remember actual form of that formula. But it is very easy to prove the formula, because when we have 2 points here, we may always think that this distance between, or this line segment which shows the distance between those 2 points, it is the hypotenuse of some right angle triangle. So I may draw here sides of a right angle triangle. I will use this kind of line. This is one side of that triangle, and here is another one, and this is right angle here. So when we have the right angle triangle there. To find out the hypotenuse, we need to find out the lengths of these two sides, which are which form this right angle here in this triangle. And when we see these coordinates here, so this Q has the first coordinate is x2, so it means it is here x2, and this point P has the first coordinate x1, so it is somewhere here. So quite easily we may see that this horizontal distance between these 2 points in this axis yes, you don't need to be sorry because I was late also, so that makes 2 of us. Okay. So this length is we can calculate the length of this side by subtracting x2 minus x1. So this length here is actually x2 minus x1, and the same in this vertical side here. The upper one has coordinate y2 and the lower one has coordinate y1, so we have here y2 and here y1. So this length can be calculated by subtracting y2 minus y1. Unfortunately, I draw the picture so badly, but let's draw there with another color. Maybe it is possible to understand what I mean. This is y2 minus y1. And then we have this right angle triangle here. So with the Pythagoras we get the length of this hypotenuse. It is Pythagoras. It is d equals this squared plus this squared and the square root of that. So it is x2 minus x1 squared plus y2 minus y1 squared. So this is actually the formula which is many times shown in these formula books. In this case it is exactly the same version. So in this example we have now, we may choose which one of these points are the first point and which one is the second point. Let's take this the first point and this the second point. So now we have x1 equals 4 and y1 equals minus 1 and x2 equals 7 and y2 equals 3. So we only need to put those numbers in this formula and we find out the distance between those 2 points. We subtract these. Actually it doesn't matter what is the order of this subtraction there. You may subtract x2 minus x1 or x1 minus x2 because there is this squared. So it doesn't matter which is the order of the subtraction. When you raise that to the power 2, the minus sign eliminates there. So in this case we have 7 minus 4 squared plus 3 minus 1 squared. this is important here to always these sign rules. You have to be very careful there, because in this case there is this minus sign, sign there, and after that you take y1. So in this case it is -1. So you have to use it in brackets, and now these -2 minuses becomes 1 plus there. So actually this is 3 squared, so it is 9 plus 4 squared, it is 16. So it is very simple. Square root of 25, or it is 5. The length of the hypotenuse of that triangle, or the distance between these 2 points there. Of course, we would be able to draw a picture of this case, and from the picture we would be able to check that if we got the right answer. But I will leave that for an exercise to you. Then this is quite important thing in many geometric, or at least analytic geometry problems. You need this formula. You need to calculate the distance between those between one or two points there. Yes.
Is it always necessary to draw a diagram for a question like this, or is it like recommended?
It is only recommended. You don't actually need to draw the picture, because this formula always gives you the right answer. So for example, in this case I didn't draw the picture of this actual problem, but this picture was only some kind of theoretic picture of whatever points.
So it is like a reference for us, right?
Yeah.
Draw it. It's quite easy for us to do the question.
That's right. Yes. Of course, I think I will draw that picture still, because I have small space here. I will draw that because it is always more it gives you some kind of vision where these points are and what is the answer. Is that a reasonable answer? So these points here, they were 4.4 and -1, so it is in here 4 minus 1. This would be the first point, and the second point 7, 3. X is 7 and y is 3, so it is in this case somewhere here. And the distance is this length, and from this picture we can see that this is a right angle triangle here, which has sides 3 and 4. So this is the famous Carpenter's triangle. This is 3 and this is 4. So the last one should be 5. I don't know why this color doesn't show well in the picture, because or in the video, because in my paper it looks like very bright color, this red one there. I think this camera is a little bit old. Let's put it more close. Okay. Let's write the coordinates there. 4 minus 1 and 7, 3. Again, the problem with this color, I don't understand. Okay, and then we will take the, in analytic geometry, one of the most common curves or functions you need is the line, straight line. And let's take something about that. Oh, I have coffee. Here, let's drink. It was already cold. Straight line. In Finnish suora. This equation, I think I will check if I find the equation from this formula book. In this case, I think in Finnish we usually use a little bit different version of that equation of the straight line. Yeah, in many times in formula books we use this kind of form of the equation of the line. Y equals, and there is some kind of K letter there. I think that K comes from Finnish word kulmakerroin. In many times, I think in English speaking world, it is quite usual to use M letter there. I don't know what you are used to use, but it doesn't actually matter what is the letter there. And this B is quite usual when we watch the picture in this formula book. This K here, Y equals K times X. K gives you some kind of vision of the orientation of this line, in which direction it goes there. Is it like this, or is it like this, or is it like this? And this B letter there here tells the place where the line intersects the vertical axis. So in this case, this is Y is the vertical axis, and there is the point B. So it is the height B, the place where the line intersects the axis, or the vertical axis. Pystyakseli or y-akseli in Finnish. So I will write in this form: Y equals K times X plus B, and this K here in Finnish it is called kulmakerroin. Probably you remember from earlier lessons when I have given you some Finnish words, and this kulma is same as angle. This is angle again. Draw a little bit. And this kerroin is coefficient or factor. And this K, I will draw a picture of this line here. Let's draw it here. Oh, sorry. And here we have y-axis and x-axis, x-axis, yeah, and y-axis. And then we have the line here. I hope this color can be seen. Let's draw it like this. So the formula of this line is as written above it. And this B always tells what is the height of the point in this y-axis where the line intersects it. So this is actually here is the point B. And as I told, this K here, it tells the orientation of this line. If we draw here some kind of triangle again, so if there is a triangle where this would be the length of the 1, if this is 1, so then this will be K. So this K always, or kulmakero in Finnish, or actually in English we call it slope or gradient. Those are, or then there are also what was the slope? I think slope is the most common word. Let's draw it here. Slope. I have another English book here. I try to find the formula there. Well, this is not this is a differentiation part there, but there is gradients of the curves, and there it is called M. This slope there, or this is also called gradient of a straight line. So it is also called gradient. Probably there are other words also, but right now I don't remember other names. So this is usually the form where the equations of lines are used to. This form we usually use for the formula of a line, but mostly when you are calculating the formula of the line, you don't find this form so easily. You first have to make some calculations there, and in many times this version of the equation of the line is more useful. I think we would use this here. This is called in Finnish pisteiden x1, y1 ja x2, y2 kautta kulkeva suora. In English, the line which goes through the points this and this. And this is the formula of it. And actually this part of here, in front of these brackets in the right hand side, this is actually the slope of that line, or kulmakerro in Finnish, this part here. I don't know if it is told here, no. Actually, I don't like this formula book so much. It is so messy and hard to find anything useful there. I should take another one next time. So let's write that formula here. Straight line going through the points x1, y1, x2, y2. And in Finnish it was like written in this, I don't know how to show that here. You can in the it is impossible to show it at the same time when you have to see this title here in the paper. Kahden pisteiden x1, ja x2 kautta kulkeva suora. Kautta is the same as through. This is a multiplication mark. And let's write that this part here, this is same as slope of the line, or kulmakerroin in Finnish. Let's take an example here. Find the formula of the line which goes through points. (1,7) and -2. Let's put 10. So now we may choose which point here is the number 1 and which point is the number 2. Quite easily we may choose that this is the first point and this is the second point, but you may choose another way also. This for the first point and this for the second point. You get the final answer will be the same, even though these intermediate steps are different. So we have these coordinates x1 equals 1 and y1 equals 7, x2 equals -2 and y2 equals 10. And after this we may find the formula here. We have in the top part of this picture or this video you see the formula there, so I will just put these numbers in the right places. y minus y1 equals difference between these points and these points here. 10 minus, sorry, I said wrong. The difference between these numbers here and difference between these numbers. So 10 minus 7 and minus 2 minus 1. And then we have x minus x1, and it was 1. I will write the coordinates here. This is y1, this is x1. If we had used the so that this second point would be the first point and this first point would be the second point, so we would get the almost exact version of this formula, but these would be in opposite directions. Here it would be 7 minus 10 and minus 1 minus 2, and here we would have the point coordinates of the point 2. Here we would have 10, and here we would have minus 2 in the place of 1. So it looks different in the first point, but or in the first stage or first step of the solution, but the final result would be the same. So now we have y minus 7 equals 3 divided by minus 3 x minus 1. It was just a coincidence. I didn't actually, those numbers I just popped in my mind, and I just chose some points there, but now we got quite easy division there, so it will be only minus 1, this number here. Usually it is not something else than whole number, but in this case it is very easy number. Y minus 7 equals, and this gives us minus 1. So in this case the slope of this line is minus 1. It is a negative number there. We will see the picture later. And let's continue. We will try to get this formula into this form. So we will have only y in the left hand side of this formula or this equation, and then we have something times x plus something. This is the usual form of the equation of the line. Y minus 7 equals minus 1 times x and minus 1 times minus 1. So it is minus x plus 1. And all we have to do is to move this minus 7 to the right hand side there, so it changes the sign. So we will get y equals minus x plus 1 plus 7. So the final result is minus x plus 8. This is the equation of the line. So this formula tells us that this line is such kind of line that it intersects the y-axis in the height of 8. And this minus in front of this x, actually it is minus 1. Well, here we saw it was minus 1. The minus 1 tells that the slope of the line is minus 1, and when the slope was seen in this picture, every time we move one unit to the right, we move k to the direct direction of the positive y-axis. And now this k is -1 here, so it actually means that we don't go upwards but downwards. So if this is 1, this k is -1, so we will go about like this, the same distance. This is 1 unit and -1 unit. So the line would be in some kind of this kind of orientation there. Let's see when we draw the picture. Let's draw a picture or graph. Picture in Finnish, it is kuva. Graph, we may, in Finnish many times we say it graphi. It is almost the same. It comes from English that word. And we are not going to use this formula yet. We are using only the points of these points which were the points where the line goes through. So we have 1, 7 and -2, 10. So I need quite a big picture now, because the y coordinate is 10 there. And let's try to draw some kind of reasonable picture there. X and Y. And then we had these coordinates here. It was 1 and 7, so X coordinate is 1 and Y coordinate is 7, so it will be in this point. And the other point is -2, -2 and so here -2 and 10. So here we will have -2 and 10 is about here. So the other point is here. And when we draw a line through those points, we get something like, I try to draw that correctly. It is about like this. And from this picture we see that the line goes or intersects the y-axis at this point here, and from this drawing we can estimate that it is about the height of 8. Here y coordinate is 8, and it is exactly the same number we got from this formula or equation of the line. So this is 8, and it looks like very good. And the slope of this curve or slope of this line was -1. So it means that every time I move 1 unit to the right, I have to move 1 unit to the down. So 1 to the right and 1 downwards, we go there. Again 1 to the right and 1 downwards, we are here. 1 to the right, 1 downwards. So this picture shows that probably we have got the correct equation of that line. These drawings or these graphs, many times they are not necessary, and many times when in actual problems those numbers or these coordinates are usually not so easy one that as in this example. They may be whatever numbers there, so mostly it is not possible to draw a very good picture of that case. But this was an example where we saw that the equation seems to give you the right answer. Okay, I will have a 50 minutes break here, so I will stop the recording and get the drink this coffee, which is quite cold now, but let's continue at the 13, what is it, 10 plus 15 is 13.25. Let's have a break.